The date of today is 1965, and I'm going to be your host, Mateo Romagno. Before we start off, I want to state a couple of facts. The age of our universe is an estimate of 10 to 25 billion years old. Not just that, but the size of our universe is also estimated to be 25 billion light years. A new discovery made by Arno Penzias and Robert Wilson, named the cosmic background radiation, states that a 6.7 degree Kelvin temperature coming from an empty space should not be common, since any empty space should have a temperature of 0. So, they were stunned by the fact that an empty space had a temperature of 6.7 degrees Kelvin. For your information, degrees Kelvin is another way of measuring temperature. They were stunned and they had no explanation for this phenomenon. Luckily, just down the road at Princeton University, some scientists had the solution. Astronomer Robert Dicke and his team were in the process of building a telescope that could detect this cosmic background radiation. What they figured out was stunning. They built a telescope that took them about 3 years to build, in between 2 to 3 years to build.
Here we are at the Horn Reflector Antenna in Oakland, New Jersey. Hey, wait. Come here, Roberto, come here. Hey, I want to ask you some questions, okay? Is this telescope difficult to make?
Oh yeah, man, actually, it's pretty hard. Like, all these metals really heavy, you know what I'm saying?
Oh.
You can see my comrades tired. But we're working hard, to create history. So yeah, I gotta go, man.
Okay. Thank you. As you can see, guys, the workers are still working, and this is to make the big telescope that will help us. We'll go back to the stage in Cosmic New Times. Remember, subscribe. Hey guys, my name is Joaquin Lacara, and today I'm going to talk to you about galaxies still misbehaving. The latest attempts to weigh galaxies are still coming up a bit short. The spiral galaxy NGC 3521 has a mass equal to the mass of 80 billion suns. The spiral galaxy NGC 972 has a mass equal to 12 billion suns. However, when we compare the amount of light coming from those galaxies, it doesn't match the amount of light we would expect from the much mass it has.
Good morning, everybody, and welcome back to the Cosmic Times. Today, we're going to talk about the supernova leave behind cosmic X-ray generators. 2 years after the discovery that the universe is awash in X-rays, astronomers are starting to pinpoint discrete sources with greater accuracy, and none of them resemble your doctor's X-ray machine. One X-ray source is called the Crab Nebula, and is the remains of a star that exploded nearly 900 years ago. It's like, wow. Those remains are often called a supernova remnant. The second source, called Ophiuchus XR1, appears to lie in the direction of another past supernova. In fact, if you drew a map of all the X-ray sources and compared it to a map of all the supernova remnants, the two would look really similar. Astronomers aren't sure what is causing X-ray radiation from these sources far away from the sun.
I'm your host, Rafael Canovas, and welcome to Cosmic Times. Today we will present an article about quasars. The astronomers have discovered that a quasar racing towards the edge of the universe is at a speed of 400 million miles per hour. That's just 2/3 of the speed of light. These and newfound quasars aren't just fast, they're really bright. The fact that they're visible to us, the Earthlings, means that these strange objects must be fantastically bright. And it is a surprise that after all these things that have happened with the quasars, nobody knows really what they are. The astronomers J.C. Greenstein and Martin Schmidt have managed to split the visible light of the quasar 3C 273 into a spectrum of color.
Come here, bro.